Welcome! This module will be all about managing your virtual machines. You will explore the creation and management of virtual machines and learn how to manage snapshots. You will discover the very handy vApp functionality and also experience the migration of a VM. The life cycle of any VM typically covers 3 phases. From creation of the VM to the use of its services until the VM is finally no longer of use and can be decommissioned. Let's examine the actions contained in each of these phases. To install a VM, the VM itself needs to be configured first. So the administrator has to make several decisions: allocating CPU and memory resources to the VM and deciding which network it will be connected to, as well as the disk size for the VM and on which storage repository the disk should be placed. The result of these decisions will be a VM, but the operating system is still missing. Most often, it will be installed from a virtual CD-ROM image hosted on a file share that is mounted to XenServer as an ISO library, but it can also be installed directly from a physical medium inserted into the CD-ROM of a XenServer host. Another common way is to deploy the operating system by booting the VM over the network, the so-called PXE boot. Some Linux systems also support to stream the installation from an internet or network source. All VMs are based on a template. XenServer comes with a lot of templates for supported guest operating systems, and each template has some settings matching the respective operating system, like, for example, the minimum required size of a disk, or whether the virtual CPUs assigned to VMs based on this template should support hot plugging. But none of these templates contain an operating system. They are just a set of configuration settings for VMs. But administrators can add custom templates to the existing templates to base future VMs on by converting a VM to a template. Usually, the operating system of a VM is updated and generalized before the conversion to a template takes place. These templates can contain additional software like antivirus scanning solutions or scripts to join a domain as well, and may save a lot of time during deployment of multiple VMs. A new VM does not need to be set up from scratch, but can also be cloned from an existing VM. Cloning requires the administrator to decide which of the 2 cloning methods available should be used: full cloning or fast cloning. Full clones are exact copies of the source VM, requiring the same space on the storage repository as the source VM, but they can be stored on any storage repository, whereas fast cloning requires the new VM to reside on the same storage repository as the original VM, since it uses a snapshot-like technology to create the hard disk for the new VM. Note that cloning VMs will provide the new VM with a different random MAC address automatically to avoid conflicts on the network layer. As a last option to create VMs, you can also import VMs saved in one of the following formats: XenServer's native XVA format, OVA or OVF, a format also supported by most third-party hypervisors. These 2 formats usually contain a virtual machine configuration and the hard disks of a VM. The OVA or OVF format can even contain multiple VMs at once. In addition to this, XenServer allows you to import hard disk images in the format VHD or VMDK, and to configure a VM based on one of these templates from XenServer to use the imported disk. Whenever a VM is imported, which is not using the native XenServer format XVA, a transfer VM is created on the XenServer host to support the import process. This transfer VM uses iSCSI and requires network connectivity to the XenServer host to transfer the content of the importable source media to a new VDI object on the selected XenServer storage repository. The transfer VM is running on XenServer as a hidden VM and is only visible during a running import or export process if XenServer is configured to show hidden VMs. This setting can be changed in the View menu of XenCenter. When the import or export action is completed, the transfer VM is deleted automatically. During the next phase in the life cycle of any VM, The most common operations are to start, stop, or restart a VM. Starting a VM means that its configured allocations for CPU and RAM are instantiated on a XenServer host with enough free resources to fulfill the VM's needs. The result is what XenServer terminology refers to as a domain. Most modern operating systems allow to turn off the hardware by issuing an ACPI power command at the very end of the shutdown phase. This command is recognized by XenServer and the respective VM is then turned off, but a running VM can also be stopped from XenCenter or using any other management tool. Stopping a VM in this way will relay the request to the operating system to perform a clean shutdown, provided the Xen tools have been installed. If the operating system is stuck or the Xen tools have not been installed, the stopping of a VM can be enforced, much comparable to cutting off the power of a computer. As this might result in the loss of data, it should only be used when appropriate. Restarting a VM is requesting the operating system to restart if the Xen tools have been installed, or if the command is forced, it will force shut down the VM and then start it again. During a restart, the domain is destroyed, all allocated resources of the VM are deallocated before the VM is started again. A restart can therefore also be used to carry out pending changes to the VM configuration, like changing the amount of allocated memory for the VM. Pause and resume are not very common actions in virtualization deployments, but they still might be interesting for special use cases. Pausing a VM saves the content of the VM's memory to a storage repository, so it can be reloaded again if the VM is resumed. Depending on the amount of memory, this may take some time, and largely depending on the installed software, a resumed VM may run into errors when, for example, running software from the VM encounters files or database records that have changed in the meantime. XenApp and XenDesktop, however, support this action to free up resources on the hypervisor host for idle desktop VMs. Bear in mind to test the VM's behavior in your scenario first before using this feature in production. As you have already learned, VMs are based on a template during their creation, and any VM can be converted to such a custom template. As part of the conversion, the hard disk of the VM is set to be read-only, so that multiple VMs based on this template only have to keep track of the changes with regard to the template's disk. All other configuration settings of the template are still editable and can be changed accordingly. Note that any VM based on the template will receive a cloned version of the disk, potentially causing conflicts due to duplicate names or IP addresses at the operating system or application level. This is why some kind of cloning preparation or generalization needs to be performed before a VM is converted to a template. While for Microsoft Windows this normally means to run the system preparation tool sysprep, any included application might need additional treatment. It is best to consult the respective vendor before creating a template. At one time, finally, a VM reaches the end of its life cycle. Maybe because its operating system is superseded, or its services are no longer needed. At this point, the VM can simply be deleted, by default including all its hard disks and optionally including all snapshots, or it can be exported using XenServer's native XVA format, or the OVF/OVA format, which is common to many third-party hypervisors. Bear in mind that any destination drive must have enough free space to fit the full size of the exported VM, and that traffic flows through XenCenter for the complete duration of the export, so exports should only be started when using a reliable high-speed LAN connection. Hello! In the following demo, I'm going to show you how to import and create a VM. Quite often, virtual appliances are made available as turnkey VMs that do not need a full installation, but a quick import and configuration. Citrix NetScaler and the licensing virtual appliance are good examples, but since any VM or snapshot can be exported, it does not always have to be a virtual appliance. I have prepared a small Linux VM which has been saved in XenServer's XVA file format, to this machine, and we are now going to import this VM to the hypervisor. First, click on File, Import to locate the file. Note to plan for enough storage space. Normally, VMs require more storage space than the size of the exported file implies. The amount of data, for example, stored for this VM is roughly 500 megabytes. But because the original VM was configured with a 4 GB disk, I can only import this VM to storage repositories with at least 4 GB free space. Next, select the hypervisor that this VM should be imported to. I am choosing to import the VM to the local storage of the hypervisor and select the virtual network card of the VM to be connected to the bonded network that we built for VM traffic in an earlier demo. Observe the status bar of XenCenter. Directly after the storage decision, the import already starts in the background to speed things up a bit. Depending on the situation, I could choose to start the VM as soon as the import process has finished, but in this case, I just want to import it. Any object that has unfinished tasks has an amber status icon, but once the import completes, you find all the settings of the VM as they have been exported. This VM is set to use 640 MB of RAM, resides on a single 4 GB hard drive, and is connected to a specific network with one interface. Note that the MAC address of this interface has been exported, but to avoid duplication of these IDs, XenCenter assigns a new MAC address to each network interface during import. If required, the import can also be done using the command line. There is an option to preserve the original MAC address. Next up, we are going to install a VM from scratch. So clicking on New VM starts the wizard, which will guide us through the process. At first, we need to decide on which template we will build the new VM to optimally adjust various settings for the respective operating system. I want to install a Windows Server 2016, so I choose the matching template and provide a descriptive name for the VM. Keep in mind that this name has no relation to the name of the operating system. Although I like to keep the names on the hypervisor the same as the names, for example, in Active Directory, this is optional and not always the case in real-world deployments. To install the operating system, I pick the correct CD-ROM image from the ISO library, which we already attached. Assign the current hypervisor host as a home server, as if I had a choice, to set a preference for this VM to always run on Hype 001 whenever possible. Since we are just dealing with a standalone server, this setting does not yet have any effect. I want this VM to have access to 2 GB RAM and to use 2 CPUs with 2 sockets, hosting 1 core each. Because the host does not have a graphics card assigned to the VM, we can skip to the storage assignment, where I could add more hard disk as required, modify the suggested size of the installation disk, or put the VM on another storage repository. But I am fine with the current settings. Let's add a network card to this VM, so it will be able to communicate on the network. I connect the virtual network card to the same network that the Linux VM is already linked to, and accept an automatically generated random MAC address. This time, I want the new VM to start up directly after its creation. You can observe the process in the status bar of XenCenter at the lower border of the window. And as soon as the VM is created, let's view the output of the virtual console of the VM. From an administrator's point of view, the following installation of the operating system is no different to installing Windows on any physical machine. Keyboard layout, product key, and edition have to be set. The license agreement needs to be accepted, and the destination drive specified before the actual installation begins. For this demo, we do not show the installation process in real time, but speed things up to the end of the installation. I just need to set a password for the admin account and the installation is finished. I used the special button to send Ctrl-Alt-Delete keystrokes to the VM and can now log on to the new VM. Since this VM is a brand new, clean installation, the para-virtualized drivers for XenServer are not yet in place and need to be installed for support and performance reasons. You can spot their absence in the device manager. Some unidentified hardware components, a QEMU hard disk, and emulated Realtek network controller. The VM's General tab formulates this as I/O not optimized. So to install the high-speed drivers and a management agent as well, I could click on the blue link or manually insert the guest-tools.iso from a special ISO library that each host has within its control domain. The installer on the CD-ROM will install all required drivers and request a reboot. And after logging on again to the VM, let's take another look at the device manager. The unidentified hardware components are now resolved. All storage and network drivers are no longer using emulated resources, but para-virtualized resources from the hypervisor that even offer hot plug functionality. Another benefit, apart from higher speed, is the availability of proper power management features and some information about the current IP address or memory usage within XenCenter. Can you spot the point at which the tools have been loaded? Until then, XenCenter only knows that the VM is given 2 GB of RAM. But after the tools have started, the actual memory usage of the operating system is reflected here. To summarize this, while the installation of operating systems normally doesn't differ from physical machines, the para-virtualized drivers should be installed right after the OS installation to benefit from better performance and manageability of the VMs. Welcome back. For the next few minutes, I'm going to explain how to create a template of a VM in XenCenter. Since the template will be used for creating VMs that use the same operating system data, some settings and properties need to be generalized in order to avoid conflicts between the descendants of the template. And while XenServer takes care of the unique IDs for VM, network and storage objects in its database, and the MAC address of the virtual network card of course, Windows normally needs the system preparation tool sysprep to run, which is what I'm going to do now. The system should be generalized and shut down right after this. Note that you cannot convert a running machine to a template. As soon as this process has finished, I can convert the VM to a template, which basically sets its hard drives to a read-only state, while settings of the VM itself remain editable. So I rename the template to something more meaningful and change the memory allocated to the VM to mere 1.5 GB, which should be enough for this demo. You can see that this VM still has its original storage and network settings. Now let's create 2 machines using this template, so I do not have to install the operating system again. Outside of this lab, your VM templates can also include updates, scripts to automate domain join or network configuration processes, pre-installed software, and so on. I used the new VM wizard again, but this time selecting our custom template, which includes an already installed operating system, and then just change the name to Win 2016 number 1. accepting all defaults since most of them are set in the template. Note the option to use fast disk cloning, which essentially means to create a new VM using a fully writable disk which only refers to the template's disk for reading data. This snapshot-like technique guarantees a quick creation and saves some storage space. If I was to untick the checkbox, a full copy of the disk of the template would be produced for the new VM, which could take some time and certainly would cost some more disk space. The new VM is created, started, and essentially just needs to be provided with a new admin password before it can be used. Bear in mind that you might still need to change the VM's name within the operating system, which in my case I want to be the same as the VM's name on the hypervisor level. While the first VM is rebooting to implement the name change, we can quickly create the second VM that I want to have for this demo. But do we have to go through the wizard again? Well, not necessarily. There is a shortcut that is called Quick Create in the context menu of the template. Use this option to produce VMs from any template, which use all the default settings. I am adjusting the name of the second VM and can then continue with anything left to do inside the operating system. To wrap this up, templates can save time, space, and might lead to more identical systems, much like cloning machines does. But be sure to take care of potential conflicts of your operating system or applications before converting a VM to a template. Templates, like VMs, can also be exported and imported to other hosts and pools, so you might even save more time. Hello. Somewhere in the life cycle of a virtual machine comes the day when it's no longer needed or superseded. Learn how to stop, export, and delete such VMs in this demo. We have a XenServer here that is already connected to a standalone host, and for the sake of this demo need to decommission the VM called Win2016-3, which is currently running. As you can see, the VM resides on the NFS storage repository with a 32 GB disk, and maybe you want to reclaim this space as well. First, let's stop the VM, either by logging on and shutting down, or leveraging the installed guest tools to send a shutdown command to the operating system of the VM. After the VM is shut down, I select Export from the context menu of the VM to transfer the VM's configuration and data to a single file on the workstation running XenServer. For this, we need to specify a path that has enough free space for the VM, including all its disks. I simply select the desktop folder. The next decision is about the file format. XenServer uses a native format called XVA, which only allows a single VM per file, but also supports the OVF format that can contain multiple VMs at once and is also widely supported by other hypervisor manufacturers. I select the XVA format and proceed to the choice which VM I want to export. Note that any running VM cannot be exported and therefore does not appear in this list. I also choose to verify the export to detect potential file corruption, since I am planning to delete the VM after the export has finished. Depending on the network speed and size of the VM, this might take a while, so for this demo we have accelerated the export. The export seems just to have finished, and you will find the resulting file in the specified export path. Note that only the blocks which are actually used on the hard disk of the VM are saved to the export file, so exporting a VM with a 32 GB hard disk can actually result in an export file of just 12 GB in size. Since the VM is now exported and verified, I can safely proceed to delete the VM. And because I also want to free up the space occupied by the VM on the host, I select to delete the disks as well. If this VM had any snapshots, they would also have been exported and could now be selected for deletion as well. To recap, use the OVF format to transfer VMs between hypervisor hosts of different manufacturers or to export groups of VMs in one go. Remember to use a network connection that can be maintained for the full duration of the export, and also provide a destination path with enough storage to possibly store the entire VM at its maximum size. If needed, the resulting files can additionally be compressed by exporting VMs using the command line or using any file compression utility after the export. Snapshots are one of the main benefits of virtualization technology. Because the snapshot preserves the VM's current state for later access, you can use snapshots to easily switch between configuration changes of a VM or states before and after a software installation or update. XenServer also supports to export snapshots to a file or creating new VMs from a snapshot, but be careful not to cause conflicts using this feature. Every time a snapshot is generated, the snapshot chain grows in its length or depth. So a VM for which you take a snapshot each month, starting in January, reaches a depth of 4 in April. Note that each member of such snapshot chains takes away some of the VM's disk performance, and that there is a total limit of 30 snapshots as far as the depth is concerned. Assume that you would revert a VM from its April snapshot state to January, install some software, and take another snapshot. Then this VM would have both a depth and a width of a snapshot tree. The depth of the current branch would only be 2, by the way, while the former April branch had a snapshot depth of 4. The width of the snapshot tree has no limit. It is only the depth that needs to be kept under 30 snapshots. It is therefore a leading practice to remove unnecessary snapshot elements from the snapshot chain to avoid performance issues. Also remember to remove or consolidate all snapshots before converting a VM to a template, since most likely the template will use the same snapshot technique to clone VMs. If no consolidation is done, all resulting VMs based on such a template would start with an already existing snapshot depth. Using XenCenter, a snapshot element can simply be removed. This triggers a process called coalescing on the hypervisor host to restructure the snapshot chain without losing any of the data contained within the removed snapshot. To help you understand how snapshots are functioning within XenServer, take a look at the 3 steps in the diagram. The first step displays an ordinary VM, which currently uses 8 GB of a configured 40 GB virtual hard disk. In step 2, the administrator takes a snapshot of the VM, causing the current configuration of the VM to be saved and the hard disk of the VM to be set to read-only. This snapshot is addressed by referring to a VDI-like object of only a few kilobytes in size, while at the same time a new writable VDI object is created, which is dependent on the read-only disk. This dependence is typically called a parent-child relationship, in which the read-only disk is the parent. Step 3 shows what happens when the next snapshot is created. The writable VDI object is turned into a read-only hard disk, just like its parent, and a new writable child VDI object is created and linked to the last read-only disk, its parent, which in turn is linked to its respective parent disks. The writable end, or currently unsaved state of any VM, is referred as the now state of the VM. This is where new data like updates or software installation is written to. What happens when a snapshot is deleted? If the snapshot is at the end of the snapshot chain, it will obviously not be a problem to just remove the data conserved in the snapshot, since it is no longer needed, and create a new writable container for the VM to use, based now on all former parent disks of still existing snapshots. But what if the snapshot that is to be removed is part of the snapshot chain somewhere in the middle? If this part would just be deleted, then all the data contained within would be lost, and all changes made after the snapshot element would be invalid, since data which they relied upon is now missing. To avoid this problem, XenServer merges the data into the next or child VDI object before the snapshot object is deleted. Step 1 shows a VM with 2 snapshots, like in the previous example. In step 2, the administrator decides to delete a snapshot which is not at the end of the chain. This is snapshot 1 in the diagram, so all hard disk data preserved in snapshot 1 is now merged to the snapshot next in line, which is snapshot 2 in the diagram. This way, the data consistency is guaranteed and the snapshot chain is effectively shortened. Welcome back. In this demo, I'm going to show how the snapshot feature of XenServer is implemented and used. For this purpose, I take a snapshot of a running VM from its Snapshot tab in XenCenter. I just enter a name, and to let it resemble a real-world scenario, I call it January. The snapshot is created almost instantly and contains a crash-consistent view of the VM settings and data on the hard disk that reflects the point in time when the snapshot was created. Any change to the VM or the data on its hard disk are now represented by the Now state, much like the yet unsaved progress in a computer game. To introduce some changes to the VM, I'm now going to install the web server role to the system. The server manager displays the results, the IIS role is visible, and the roles counter now counts to 2 installed roles. Let's assume a month has passed and we now want to save the current state of the VM as a new snapshot called February. This saves all the changes that happened since January as a difference disk for each hard disk of the VM. Therefore, the February state alone would not be of any value. It depends on the existence of the previous state, which is January in our case. Again, I am adding the print server role to the machine and take another snapshot and call it March to fit into the story. Note that there is also the option to save the memory contents of a VM alongside its hard disk data, but this might as well cause time traveling problems for applications or the operating system. The Windows server now counts 3 installed roles, but let's assume we need to go back to an earlier state of the VM where these roles have never been installed. This is especially useful with faulty hotfixes that cannot be uninstalled otherwise. From the context menu of a snapshot, I choose to revert to this point in time copy of the VM, which brings up the question if the current state of the VM, which might contain unsaved changes of value, needs to be saved as a new snapshot before reverting. Pay attention that there is no option to get back to the current now state once the VM is reverted, if it is not saved here. I decide against saving the now state, so a new pointer, a new now state, is generated in dependence only from the January state of the VM. From point of view of this now state, February and March have not only never happened, they most likely never will. Because the snapshot was taken of a running VM, reverting to this snapshot also starts the VM trying to match the captured state of the VM that it was in during snapshot creation. So, to verify, I log onto the system and you will find that only one role is installed. No trace of a web server or print server roles are visible in this state of the VM. To represent another change, I install OpenOffice to the server and take another snapshot of the VM called April. XenServer shows the snapshot chain like a tree with branches forking in different directions. Take a closer look at the context menu of the snapshots. We could export the state of a VM just like a normal VM and later import it, maybe on another server. Also, new VMs can be created from any snapshot, but take care not to cause conflicts by running the same VMs from different point-in-time copies. To clean up and to keep the snapshot chain short for performance reasons, you can safely delete any snapshot that is no longer to be used. In the background, XenServer will merge the contents of the snapshot to the next in line to avoid gaps and prevent corruption of the snapshot chain. To sum this up, using snapshots within XenServer is very easy, but be sure to understand the implications on performance and potential conflicts. Also be reminded that snapshots do not substitute a backup solution as long as they are stored on the same media, but they can be a vital part of a backup strategy. The migration of VMs refers to one of two XenServer features. XenMotion describes the non-disruptive transport of a running VM between two hosts of a pool, while storage XenMotion indicates the non-disruptive transfer of a running VM between two storage repositories, either within the same pool or crossing pool boundaries. Note that only VMs can be migrated by XenMotion, which are not bound to a resource which is unique to a single host, like the physical CD-ROM of a host, for example. A common requirement for any migration of VMs is that XenTools must be installed on the VM, and the destination XenServer must have enough storage and RAM resources available, matching the VM's requirements. A migration is also only possible for hosts running the same or a higher version of XenServer compared to the source host. Storage XenMotion also requires that the VM to be migrated does not have more than 6 attached hard disks. Note that storage XenMotion is not supported for desktop deployments, since especially machine catalogs created by the machine creation services need to keep track of the VDI objects and their storage locations. To help you better understand what is happening during XenMotion, take a look at the left diagram. Only then is the running VM or domain destroyed on the source host and instantiated on the destination host, which now starts using the VM's hard disks on shared storage. Storage XenMotion includes the same process at a later stage, but uses a similar process to synchronize the VM's hard disks one by one first. And as soon as any hard disk is synchronized between source and destination host, any data written to the hard disk is written to both copies of the disk at once. They are now mirrored. When all hard disks are identical on both hosts, the XenMotion process transfers the memory contents as usual, and the running VM and its hard disk data is destroyed on the source host and instantiated on the destination host, which now uses the mirrored hard disks. A common use case for storage XenMotion is the purchase of new hardware running in a separate XenServer resource pool. All VMs can be transferred without downtime to the new pool, but due to the expected loss in performance, remember to plan this migration in times where business activity is lower. Another use case is the migration of VMs to a different storage repository. Previous XenServer versions required to export VMs first, delete the VMs, and import them again, specifying the new storage repository as destination. Using storage XenMotion enables administrators to move VMs and their hard disks to new storage repositories independently of their current power state. Welcome to the next demo. This time I'm going to explain what happens during a so-called live migration of a virtual machine. While XenServer supports relocating a running VM without downtime from one host to another host within a pool, it also supports the shared nothing migration, where a running or stop VM is transferred to a different host which is not part of a pool with the host the VM currently resides on. For this purpose, I have created a Windows-based VM, which you can see is running at the moment, and to give it a more realistic touch, I also have logged on and opened up 2 applications containing unsafe data. Both apps react to my interactions. This VM sure is live, and currently resides on the origin host Hype001 for this demo. Now let's connect to the destination host for this VM by adding a new server or host to XenServer, using its management IP address and valid credentials to log on. There it is. Hype002 does not yet contain a VM at all, and its storage repository is yet unused. But bear in mind that you can only migrate VMs to hosts that have enough free storage space available, matching the VM's requirements. Within the context menu of a VM, I choose to migrate this VM and select the destination host from the list of hosts currently connected in XenServer. You could also add the destination host during this step of the wizard. After the host has been selected, I can choose to put all the disks of the VM onto the same storage at the destination host, or name a specific storage repository for each disk. Since the destination host in our demo only has one storage configured anyway, I just click Next to accept the default. Also, I need to select a network on the destination host for each network interface of the VM to be attached to, before having to specify which network should be used for the transfer of the VM itself. Note that this network can be any management network or storage network over which the origin and destination host can reach each other respectively. The migration process has started, and the status bar of XenServer reflects the progress, as does the events view within the notifications menu. Since migrating the VM requires copying a snapshot of the VM's disk to the destination host first, and additionally synchronizing the memory contents until they match on both sides of the migration, the actual migration process can take some time, mainly depending on how much data is changed during each synchronization pass. For this demo, we have accelerated the display of the process. By now, the VM should almost be finished with its migration. You can still see the screen output, and I could still interact with the programs as well. For the final phase of the migration, you can see the copy of the VM on the destination hypervisor host, but it has not yet been started. Starting this VM is not comparable to the normal boot process of any OS, but more to resuming a laptop from its hibernation state or deep sleep. The memory contents of the VM have been synchronized to the destination host, and the VM is now powered on using this memory contents. So it is already booted, and all programs are still running with their respective data. At the same time the VM is started on the destination host, the VM is stopped and destroyed on the origin host to avoid conflicts between the two VMs. You can see that the VM reacts to my input, windows are movable, and new programs can be started. To wrap this up, XenServer supports relocating VMs to different storages and networks of stopped and running VMs. To transfer a running VM, the Xen tools need to be installed within the VM first, and the VM must have no more than one snapshot. The destination host must have CPUs from the same vendor as the origin host, and does not have to be part of the pool with the origin host, which makes the shared nothing live migration the perfect tool to avoid downtime during hardware maintenance and stepping up to newer hardware. XenServer supports the creation of vApps, a kind of grouping mechanism to declare the order in which VMs are started and stopped. Each VM associated with a vApp can be set to a starting order, which is just a numeric value and may be given a time value to wait before other VMs are started. When a vApp is started, all VMs configured with the lowest start order value will be started first, Then all VMs with the next higher start order value will be started, and so on. If any VM has been configured with a time value to wait before other VMs are started, the starting of VMs of the next higher start order value will be delayed by this time before these VMs will be started. Note that VMs can belong to a single vApp at any given time only, and vApps cannot be nested. An exemplary use case for vApps is the XenDesktop infrastructure. The domain controller VM is assigned the lowest start order value together with the router VM, maybe providing internet access. Both VMs are configured to delay the start of VMs with a higher start order value for 1 minute in case of the router, or 3 minutes in case of the domain controller to finish booting. When this vApp is started, the domain controller and the router are started in parallel, but the next VMs, that is Storefront or STF, and the SQL Server, are started after the 3-minute delay has passed. The SQL Database Server VM has been configured with a delay of 4 minutes, so the PVS and XDC VMs have to wait 4 minutes before they are started. This way, administrators can ensure that required services are available before starting VMs depending on these services. Note to plan for some extra time to compensate performance issues during times of heavy usage or during disaster recovery. In this module, you have learned to install XenTools on every guest VM to support special features like XenMotion, provide higher performance, and be eligible for support. You are also now familiar with snapshots being a representation of a VM's data and configuration of a specific point in time. You learned to avoid performance problems by keeping the snapshot chains short and explored storage XenMotion to migrate VMs across resource pool boundaries. In addition, we talked about the vApp feature of XenServer to offer a logical grouping of your VMs, including preferred start orders and delays.